Hello everyone, welcome to what will be pre-lecture number 36. We're going to do some nomenclature review and practice in this pre-lecture video, and then we will do some review from other concepts in class. So getting into things, just a reminder from last class about oxidation numbers. Basically, these are the order of rules that we follow in order to assign oxidation states or charges that help us balance electrons within molecules. And so I will let you read through these on your own, since I won't bother taking up your time with me reading them. But hopefully these all look familiar, and as you're practicing these, basically I think if you do enough practice, these should become second nature. Okay, so let's do some practice with that. And I'm going to do the examples in blue in this video. Obviously, if you would like more practice, there are more molecules here, ever more molecules in your book, and so if you would like more practice, that's how you would do it. First example here, though, we have PO3 3-, and so if we were to look at our oxidation state rules, the first one that we would come across is that our total charge for the oxidation state of our phosphorus and the oxidation states of our 3 oxygens needs to add up to -3. Okay, so that's one of our rules. Then if we started assigning oxidation states to our individual elements, our rule says that oxygen should always be 2-, right? And so if oxygen is 2-, and we have 3 of them, that is a total of 6-, right? And if we have 6- and we know our total charge has to be 3-, we just need to be able to make up the difference between that with phosphorus. And so, of course, the difference between 6- and 3- is 3. So phosphorus oxidation state is going to be 3+. Okay, and that leads us to our oxidation states. Oxygen, again, would be 2-, phosphorus 3+. Okay, so that is one example. Next example, we have P2Cl4, and in this case, we know all of our oxidation states need to add up to 0. If we don't have any charge shown, positive or negative, we can, of course, assume that our charge will be 0. So with that, if we were to go down our list of rules, the first one that we would encounter that would be relevant here is that chlorine is in group 17 on the periodic table. And based on what we know, chlorine should always have a charge of -1 when that is the first rule we encounter. So Cl will be equal to -1, and we have 4 of those. And that means that our oxidation state for chlorine is going to be -1, and that gives us a total charge, negative charge, I should say, of -4. That means with our 2 phosphorus, we need to have a total charge of +4, right? And we have 2 phosphorus, so basically what times 2 equals 4? Hopefully that math isn't too hard for you. It should, of course, be +2, right? So our oxidation state of phosphorus in this example is +2. Our oxidation state of chlorine is -1. Next example, carbon tetrachloride, right here. It's a covalent compound, like I guess really all of these are. Well, our first 4 examples at least, our last 2 are ionic. So with this, carbon tetrachloride, first rule again would be that Cl should be 1-, so Cl equals -1. We again have 4 of them. This time we only have 1 atom though, so with carbon, we know, so this has to equal -4. We know carbon has to equal +4. And if we only have 1 carbon, that means this should be +4. So pretty easy oxidation state assignment for that one. Chlorine will be -1. Carbon will be +4. Next up, carbon monoxide. So in this case, we just have carbon and oxygen. If we were to go down our list of rules, oxygen should always be 2-, so oxygen will be 2-. If we know that our molecule is neutral here, no charge overall, that means carbon has to balance that charge, So carbon will have an oxidation state of 2 plus. Okay, 2 plus, 2 minus, pretty straightforward, right? Next up, we have an ionic compound, so iron nitrate, iron 2 nitrate, I should say. And so if we're looking at this, we should know, hopefully at this point, nitrate is always a -1 charge. That's one of our polyatomic ions. So I'm going to split this up into iron. And because we have 2 nitrates that we know are -1, our iron has to be 2 plus to balance that charge. And so we know that each nitrate, NO3 minus, is equal to a -1 overall. But if we break that into its constituent elements, meaning nitrogen and oxygen, we know that if we were to go down our rules, oxygen should have an oxidation state of -2. And when it has an oxidation state of -2, and we have 3 of them, then we have a total charge of -6. And that means that nitrogen has to balance that. And we have 1 nitrogen. And we need that negative difference between -6 and -1 is, of course, +5. And so that means nitrogen's oxidation state is +5. So if I asked you for the individual oxidation state, or the oxidation state of every element, iron would be 2 plus, oxygen would be 2 minus, nitrogen would be +5. Okay? And lastly, we have aluminum sulfate. We don't need to specify like aluminum 2 or aluminum 3, depending on what it is, which we'll get into in a second, because aluminum is in the 13th column of the periodic table, group 13. It should always, as an ion, have a 3 plus charge, right? So that's one of the ones that we can figure out by looking at the periodic table. And so aluminum 3 plus has an oxidation state then of 3 plus. Then if we break things apart again, sulfate, SO4, hopefully that's one of your polyatomic ions we know. We should know it has a charge of 2 minus, but even if we just know aluminum's charge, we can figure out what sulfate's charge is, which is 2 minus. And so we know that the oxidation states of our 4 oxygens and our 1 sulfur have to add up to -2. And so if we start to break that out, again, our rule, one that we use a lot, oxygen always has an oxidation state of -2, unless it's with hydrogen peroxide. And because it has a charge of -2, we have 4 oxygens for a total charge of -8. And our sulfur needs to balance that to get it to a charge of -2. And so we don't know what sulfur's oxidation state is. We know we have 1 of them. And our difference between -8 and -2 is, of course, +6. And so sulfur's oxidation state would be 6 plus then. So final answers here. Aluminum has an oxidation state of 3 plus, oxygen, oxidation state of 2 minus, sulfur, oxidation state of 6 plus. Okay? Hopefully that was helpful in assigning oxidation states. If you do have any questions, please let me know. Otherwise, I hope you have a great day, and I will see you soon.